Right, we are here and we want to discuss the module MAT2691. It is mathematics for engineering. But now, looking at mathematics for engineering, I want us to pay specific attention to matrices for a start. And now I'm having here with me in front of us a 2 by 2 matrix, very easy. We shall look at larger matrices as well. But let's look at the solution to this. Right, the solution to this matrix of the 2 by 2 size, and the matrix is A. 8, 9, 4, 5, like this. What is the inverse of this matrix? We want to find the inverse of this matrix. Right, so to find the inverse of this matrix, we proceed as follows. We first get the determinant of this matrix. What is the determinant of A? So you can just cross this out. 8 by 5 minus 4 by 9. That is the determinant. And so what is 8 by 5? It's 40. And this is 36. The difference is 4. And hence the conclusion is that the determinant of the matrix A is 4. Right, after having obtained the determinant of this matrix, we proceed to look at thus. If the matrix A has already been seen to be 8, 9, 4, 5, this means, therefore, that the inverse of this matrix is 1 over the determinant of A into, you interchange these two, and you put the 5 here and the 8 here, and this is minus 9 minus 4. And this means the inverse of A is 1 over the determinant, 1 over 4 into 5 minus 9 minus 4, 8. Multiplying through here, we have that this is the same as 5 out of 4 minus 9 out of 4 minus 1. The chord of 8 is exactly 2. And this is the exactly the matrix that is required here. Okay. Here is another question in front of us. This question is about matrices as well, but it is focusing on another aspect of matrices, because sometimes these matrices are brought differently. And that not just give a matrix sometimes, but instead they give a story. And here is the question. An example. Right, so in this example, we are focusing on the kinds of matrices that emanate from story sums, word problems. And here is the question. It says use matrix method. Right, use matrix method. And the inverse of the coefficient matrix The inverse of the coefficient matrix. To solve, the following problem. Here is the problem. A company manufactures robotics. Robotics or robotic controls. They are current modules. Current modules are the RC1 and RC2. Right. Each RC1 unit requires 8 transistors and 4 integrated circuits. Each RC 2 unit requires 9 transistors and 5 integrated circuits. Okay, and 5 integrated circuits. Each day, the company receives 1,596 transistors and 860 integrated circuits. Integrated circuits. How many? Right. How many units of each model can be made? With all the parts, with all parts. Parts. Right. Are used. That is the question, and we proceed to look at the solution to this problem. Right, looking at the solution, a couple of things we need to consider to solve this problem. So there are mostly two instances where you have the RC1, but there's also RC2. Right. Let me write as follows. Right, obviously you have the RC1 and 2, but most importantly, you have components we call transistors. And you have RC1, RC2. Right, and then also, but you also have the integrated. Integrated, like so. So if you look very carefully, right, a company manufactures robotic or robotics controls. Their current models are RC1, RC2. Each RC1 unit requires 8 transistors and 4 integrated circuits. So RC1 requires 8 and 4 respectively. Requires 8 transistors and 4 integrated circuits. And also here, each RC2 unit requires 9 transistors and 5 integrated circuits, so 9, 5. You have 9 here, you have 5 there. Right, now each day the company receives 1,596 transistors and 860 integrated circuits. So you have here 1,596. And then here you have 860. And so what does this mean to us? Right, it means a couple of things here. So you can write these and say, for instance, 8RC1 plus 9RC2, 1596. 4RC1, 5RC2, 860. And so we proceed. From this point onwards, you can let X be the RC1 and Y be RC2. And therefore here you have 8X plus 9Y. 8X plus 9Y equals 1596. 4X plus 5Y. 4X plus 5Y is 860. Like so. Okay, what do we do now moving forward here? So we have the matrix equation. We're doing matrices for a start. There are a couple of other things we're going to do today. Right, so the matrix equation Right, so the matrix equation is of the form, for example, 8, 4, 9, 5. And you have 8y is equal to 1596, 860. That is called a matrix equation. So in other words, now we usually call row by column multiplication. So if we just factorized this into this matrix equation, but you can multiply again. 8 by x is 8x, 9 by y is 9y, 4 by x is 4x, 5 by y is exactly 5y, and the right-hand side are the constants there. Okay, right, so we then need to solve this. So we then have the 8, 9, 4, 5, x, y, 1596, 860. So what is the answer to this here? So the answer to this is actually as follows. So to solve this, we solve it like a basic linear equation. So because of the matrix here on the left, we move it to the right and we multiply both sides by the matrix inverse of the coefficient matrix. But because it's on the left, it's going to also be on the left of the right-hand side. 1596860. Okay, if you look carefully, now we have the inverse of this, but we got the inverse of this matrix before. And this matrix had the inverse what? Minus 9 over 4, minus 1, 2. 1596860. Like this. So we got the inverse of the matrix before, and it was exactly this, and we are carrying that inverse forward. And we just brought it forward right now, and we have exactly that. But at this point, having, for example, the xy multiplied by the matrix inverse, we just got 5 out of 4 minus 9 out of 4 minus 1 together with 2 multiplied with 1596, 860. Which is this? This by this minus 9 over 4 by 860. Relatively large numbers, but I expect that to be 60. So now you take this row and multiply by this column. So it's minus 1 by 1596, which is minus 1596. And then we have 2 times 860. So if you look at that carefully, 2 times 860 minus 1596. Right. And what we're getting is 124, like so. Therefore, x equals 60 units of RC1 and Y is equal to 124 units of RC2. And so this is the answer. And we're done with that matrix question. But we want to solve more matrix problems. And we continue to analyze these in some very good amount of detail. And let us pay particular attention to the next problem. Right, to the next problem, and here is the next question. Right, obviously we are doing a mixture of this. We shall be doing lots of... Now, here is another example. This example is an example that focuses on calculus. And it says find the integral of twice x, the sine of x squared dx. The question becomes, how do we do this? How do we do this? Right, in doing this, there are a couple of things we need to consider. We let u be exactly x squared. And that means du, the derivative of this, is twice x dx. So that if we consider the integral of twice x, the sine of x squared dx is twice x, the sine of u, dx is du over 2x. This cancels, which means you have the trigonometric sine of u du. What is the integral? The integral of this is minus of the sine is minus cosine. U plus c, which is minus cosine of x squared plus c. So we have solved this integration problem. Okay, obviously this was an indefinite integral without the limits of integration, but there are more problems with limits of integration. Here is the next example. So in the next example, we're looking at what it means to look at a definite integral. Definite integral. Looking at integration techniques. And the question says, determine. Right, determine the integral from 1 to 2 of the natural log square of x dx. We look at the solution to this. Okay, so let's look at this. So we're going to be using a technique we call integration. Integration by parts. Because now we have the square of the natural log. And so having the square of the natural log requires us to use integration by parts. What is the formula for integration by parts? The integral of u dv is uv minus the integral of v du, like this. So we let u be the natural log squared. which implies that du dx is what? Okay, this one here is you bring down the 2, so it becomes 2 ln x, and you subtract 1 from the 2, getting a 1. Then you multiply by the derivative of ln x, which is 1 on x. 1 on x, like so. And so what is the meaning of this? So in other words, if you choose that u is the ln squared, so simultaneously it means that the remaining, you choose u to be the ln squared of x, so dv is what remains, which is the x. You integrate both sides. If you integrate dx, you get x, like so. What's the answer? The integral of the ln squared dx. It must be first u. What is u? We chose u to be the ln squared of x. V, we got it to be x, minus the integral of v, which is x, du. What is du from this? Du is 2 ln x over x dx. Is 2 ln x over x dx. That is du. V du. Okay, we're using the v du in the integration by parts formula because that is what is important. Okay, and that is what the formula states precisely. Okay, now, which means that I have deliberately left out the limits of integration because I want us to focus on evaluating first the integral, and then we shall, okay, these cancels here, the 2 can be factored out, and you have the natural log, like so. Now, here we have again the same thing, so you need to use integration by parts twice. So you let u be ln x. Whatever remains is dv, which is dx. Let's find the derivative of this. Du is 1 over x dx. The derivative of the ln is 1 over x. If you integrate, if dv is dx, then you integrate dx, you get x. Meaning that if you have the integral of the ln of x, the x is, okay, obviously this is relates to our integration by parts formula that we can put in a small a rectangle here. So u dv is uv minus the integral of v du, and that is the integration by parts formula, this one. Okay, if this is the integration by parts formula, then what do we do here? So it is u. What is u? Is ln x. What is v? It is x minus the integral of v, which is x du, 1 over x dx, like this. So x cancels, meaning you have x, then x minus the integral of dx. X ln x minus x. Oh, we can add a c here, an arbitrary constant of integration. Okay, so we have done the integral. So the integral of the natural log of x dx is x ln x minus x. So that now at this point, if you have the integral squared dx, what is this integral? This integral is exactly x ln squared of x. minus 2. The integral of ln x dx. The integral of ln x dx is the same as x ln x minus x. X ln x minus x. Okay, leave out the c. Right, so you can add c like this. The integral of the ln squared is the same as that. So this here is x. It is equal to x, the ln of x squared, minus twice x, ln x, plus twice x, plus c. So now, hence, if we perform the integral from 1 to 2 of the ln squared x dx, you write the right-hand side of this particular integral, which is the result after integration, plus twice x. You integrate from 1 to 2. The integral from 1 to 2 of the ln here, dx, which is 2, the ln of 2 squared minus 2, the ln of 2 plus 2, 2 minus substitution by 1, which is exactly 1, the ln of 1 squared minus 2, 1, ln 1 plus 2 times 1, like this. And this is the integral of 1 to 2 of the ln squared of x dx. And this equals, right, in view of the right-hand side of these, you'd get exactly the figure that this one here is 2 the ln. It is exactly 2 the ln of 2 squared. 2 by 2 is 4. It's minus 4 ln 2. Minus 4 ln 2 plus 4. And then this ln is 0, and this is 0, and then this one is minus 2. So the integral performed from 1 to 2 of the ln squared dx is 2 the ln of 2 squared minus 4 ln 2 plus 2. So this is what we get. And this is the answer. And we are done with solving this problem. Okay, there are many problems that we're going to do today to practice our integration, because integration is quite an interesting part of this module, but also we shall spend time on many other parts that constitute the exam. Let's look at another example. Right, in this example, we are trying to analyze this and see what we can do. So we're looking at the integral with respect to x of 9 plus 4x squared. And the question says, evaluate. Let's look at the solution to this. Right, so looking at the solution to this, what do we do? Very straightforward question in front of us. The solution is as follows. We're looking at the integral dx. 9 plus 4x squared, which is the same as what? This integral here. We can write it as the integral with respect to x. 3 squared 2x squared. Like this. And so what is this? If you find the derivative of the 2x, derivative of 2x with respect to x is exactly 2, meaning that we can put 1/2 and then put 2 over 3 squared plus 2x squared dx. So the derivative of 2x is 2. And what is then the answer to this? If this is the case, the answer to this becomes the 1/2 is there. So it becomes 1/3 times the arc. We take the arctangent of twice x over 3 plus c. What is the final answer? Because if you multiply 1/2 and 1/3, we get 1/6. So that the integral of dx over 9 plus 4x squared is 1/6 arc. 10 of 2x over 3 plus c. And that is the answer. We look at the next example. Right, in the next example, we're looking at how to deal with more advanced integrals of the following nature. Integrals involving radical signs. And here comes the question, and it says, evaluate. Here we need to evaluate the integral of x divided by the square root of 27 minus 6x minus x squared dx. So look at the solution to this just now. Very, very easy question, but we're practicing here. Okay. All right, so you continue. What is the solution to this? The solution. All right. We continue. So now we then say, so you're gonna let u be exactly 27 minus 6x minus x squared. And what is this? So you're gonna find du dx. So this one is 0, and therefore we have minus 6 minus double x. And which means we can find dx, which is exactly du divided by minus 6 minus twice x, like so. And so what is this? What is this? It's very straightforward, and we continue to solve this problem in detail, but also to solve this problem in a step-by-step manner. Right. The couple of things, obviously, we need to take into account here, because these can also be written as dx is du divided by, if you factor out minus 2 here, it is 3 plus x. Okay, but obviously looking at this, you can see that it doesn't immediately cancel with that. So it means, therefore, we must do something extra. And this is what we're going to do. We have the integral of x. So in the denominator, we have the square root of 27 minus 6x minus x squared dx. But these can as well be written as, right, we can introduce a minus 2 in the denominator so that we multiply the x by minus 2 so that these two cancel out. Right. Right, so now we put minus 6 plus 6, because minus 6 plus 6 is 0, and then this minus 2 cancels out. So this is exactly the same as the original question, but it is undergone some transformation. So we're good. Which means, therefore, here we have 27 minus 6x minus x squared dx. dx. Okay, so this is extremely important for us. But what is the meaning of this? So this is exactly the same as this can be broken down into minus 2x minus 6 divided by minus 2. The integral of 27 minus 6x minus x squared dx plus 6 divided by minus 2 times the integral, and then here you have 27 minus 6x minus x squared dx, like so. And so what is this here? Like we saw before, This is the integral of minus 2x minus 6 minus 2 u, the square root of u, dx wrote it as du divided by minus 2x minus 6 before, but it is added to the integral of 6. You divide it by minus 2, the integral of 36 minus x plus 3. And then you square this, dx. And so this is what we have. Now, what is all this here? This cancels out. If it cancels out, then we can be able to take the integral here. This cancels, and now when this cancels out, you have the minus 2, the minus 1/2. And you have u to the minus 1/2 du. Plus here you have the integral. But this one you can already transform because you can divide 6 by minus 2, getting a minus 3. The integral of 1 over 36 minus x plus 3 dx, which is minus 1/2. The integral of this one here, you add 1 to minus 1/2, so 1 minus 1/2 is 1/2, and you divide by 1/2, so what that brings is a 2. U to the 1/2. And therefore, the integral of this here, 36 is the same as 6 squared. And therefore, this is arc sine is minus 3 arc sine of x plus 3 divided by 6 plus c, which is minus u to the 1/2 minus 3 arc sine of x plus 3 plus c. Okay, this is minus the square root of u minus 3 arc sine of x plus 3 out of 6. What is u? It is 27 minus 6x minus x squared minus 3 arc sine x plus 3 out of 6 plus c. And so this one here is the result. So what is the conclusion here? Well, the conclusion, therefore, is that hence what we have here is the following. Right, is the following that we have. Right, I'm going to clean this up. Okay, so hence the integral given to us the integral of x divided by the square root of 27 minus 6x minus x squared dx. This integral is minus the square root of 27 minus 6x minus x squared minus 3 arc sine x plus 3 out of 6 plus c, and this is the answer. Next question. It's very important that you're able to calculate the root mean square values. Let's look at the RMS values. An example. Right, in this example, we are going to be looking at specific things, but most importantly, RMS calculations. The question says determine the root mean square value, which is the RMS of y. Y equals 1 over the square root. 1 plus x squared. Like so, between x equals 0 and x equals 3. We proceed to look at the solution to this problem. Okay, just a sec. I forgot to connect my system here to the power source. That's okay. Right, so we're looking at the solution now. So now to find the root mean square of this, it's very straightforward, but we must know the formula for this. So we note that there are a couple of ways to write this out, but the root mean squared b minus a, the integral of a to b y squared dx. So this is the formula of the root mean square. And so now we're going to calculate here between exactly the values given between x equals 0 and x equals 3. Okay, so we solve this problem and we continue solving these as follows. So right now we have the following. Right, follows therefore that the root mean square squared is the same as what? Right, we've already said a couple of things about the fact that it is exactly the same as 1 over b minus a to b y squared dx. Squared. So what do we do here to get the answer? So we need to analyze this with caution and be able to realize that we have the origin, but also we have the couple of the values here that are required. Okay, there's something I'm going to mention just now here. And so is to consider the fact that the function here, y, is actually equal to 1 over the square root. 1 plus x squared. So that what we then do here is to then find the b and find the a, which are the limits of integration. So the question becomes, what are the values of b and a? Remember that this is from x equals 0 to x equals 3. So that as a consequence, what we're getting here is as follows. Right, so your b here is 3. So in other words, your a is 0, your b is 3. 3 minus 0. The integral from 0 to 3 of the y, which is 1 over the square root, 1 plus x squared. You square this, dx. So this is the root mean square. That you square is 1 out of 3. The integral from 0 to 3, if you square the square root, it becomes 1 plus this. So what is the integral of this? So it means that the root mean square is 1 out of 3, and therefore this one is arctan. The integral of 1 over 1 plus x squared is arctan. Arctan of x from 0 to 3. And so which means the root mean square. 1 out of 3. Arctan of x. The integral from 0 to 3. 1 out of 3. Arctan of 3 minus arctan 0. Root mean square. 1 out of 3. Right, what is arctan 0? The tangent function is 0 at the origin. So, which means that this is arctan 3. And it is a couple of implications about the fact that the root mean square is the square root of 1 over 3 arctan 3, which is 1 over the square root of 3 times the square root of arctan 3, like so. This is not the only way to write the answer, but you can say the root mean square is 1 out of the square root of 3 times the square root of arctan 3, like this. Okay, the next question. So the next question is a very interesting one, but very, very easy, but interesting. So let's find the volume of a solid of revolution. Another example. Right, in this example, we shall be focusing on what it means to calculate, what it means to actually calculate the volume of the cone generated by revolving the area between y equals 2x, the y-axis, and the line y equals 5 about the y-axis. Solution. We analyze this and we continue. Right, if we need to calculate the volume of the cone generated by revolving the area between y equals 2x, the y-axis, and y equals 5 about the y-axis. So this question looks at what happens when you perform, when you consider yx and then you have y equals 2x. Calculate the volume of the cone generated by revolving the area between y equals 2x, the y-axis, and the line y equals 5. So there's a line here, y equals 5, and the y-axis. So this is the area of interest. Right, so if this is the area of interest, we want to find that area. How do you find the volume? If this is revolved around the y-axis, here comes the solution to this. Already, obviously, we're dealing with a solution. It's okay. Right, so now here we need to use the correct formula. Volume. Volume equals pi. So it is like a circle. So we find the area of the base by the height. So it's pi radius squared times the height. So it becomes pi a to b x squared dy. But we make a couple of observations that since the graph is revolving about the y-axis, it's revolving about the y-axis, therefore our equation Okay. Our equation is x equals y on 2 x equals y on 2. Now, if this is true, that would therefore mean the volume is pi 0 to 5. Y out of 2 squared dy pi out of 4 0 y squared dy pi out of 4 y cubed out of 3 from 0 pi out of 4 by 3 is 12. Okay, so obviously, I mean, from y equals to x, we can see that x is y on 2, and the y is from 0 to 5. So now, what is all this? 5 cubed. 125 pi out of 12, which means V is 3272 cubic units, like this. Okay, so that is the answer. And then we continue solving more problems. And the next question is very interesting. Is finding the inverse of a matrix, but a much larger matrix of 3 by 3 size, matrix of order 3, order 3 by 3. In other words, another example. And this question says, determine the inverse of the matrix A 250 minus 370 minus 37 minus 1 5 minus 3 minus 1. Using
Sorry, is the last one minus 1, or is it just 1? The
this
bottom
one
is
is just
5.
1.
Okay, all right, okay.
Your 250 minus 37 minus 1, 5 minus 3 plus 1. Right, using the adjoint method. Using the adjoint method. What is the solution to this? Let's investigate. Right, so this is a very, very interesting question, but very, very straightforward. So we analyze these together. What do we do here? To find the inverse of this matrix, you must first find the determinant because you must use the adjoint method. The adjoint method requires the evaluation of the matrix determinant. So we find the determinant next. To find the determinant, we must write down the matrix A. And it's exactly 2, 5, 0, minus 3, 7, 0, no, minus 1, this one is a minus 1 here, and you have 5, minus 3, 1. The determinant of the matrix A. So you use cofactor expansion. Plus, minus, plus, minus, plus, minus, plus, minus, plus. Okay, so what is the answer? 2. 7 minus 1 minus 3, 1. Minus 5. Minus 3, 5, minus 1, 1. Minus 3, 7, 5, minus 3. Seven by 1 is actually 7 minus 3. Like so. Minus 5. Minus 3, if multiply this by this, is minus 3 plus 5. Plus 0. This is going to be 0, obviously, but minus 3 by minus 3 is plus 9. Then you minus 5 by 7, 35. Like so. What is the answer to this? Well, the determinant. Okay, so 7 minus 3 is 4 by 2, 8. So this is 2, which is minus 10. Okay. So that is what we have. Right, so having obtained these, what next do we do? We find the minus and the cofactors. So we're just going to find quickly the cofactors. Okay, so now we have found with us here the determinant of this matrix. So let's pause and just check that there is nothing wrong with this matrix here. And there's nothing wrong with the determinant as well. So we must look at this and think very, very carefully. So then think about this and make sure you're okay. Right, make sure that the determinant is correct. Yes, it is correct. Now the next thing is that we're going to find the cofactor matrix. Cofactor. Cofactor matrix. how do we find the cofactor matrix? So now the cofactor matrix would consist of the cofactor matrix of the matrix A. What is the matrix A? Right, 250 minus 371. Okay, I'm just going to clean this up, please. All right, just going to clean this up. So I'm writing down the matrix A. So it's 250. It is minus 3, 7, minus 1. It is 5 minus 3, 1. So what do we do with this now? Want to get the cofactor matrix? So the cofactor matrix is obtained as follows. The matrix, the cofactor C11. So in other words, so there's a formula we use. The cofactor formula. Cofactor formula. Cij is minus 1 to the I plus j times the minor, like this. So in other words, Cij is the cofactor of the entry in the ith row, jth column, which is minus 1 to the power I plus j times the minor of the entry in the ith row, jth column. And now we're going to find the cofactors together. Let's find C11, for example. C11 is going to be minus 1 to the power 1 plus 1 times the minor of the entry in the first row, first column, so which is 7. If you block this column and that row, you are left with 7 minus 1 minus 3, 1. And this is exactly the same as 1. 7 by 1 is exactly 7 minus 3, which is 4. C1, 2, which is minus 1 to the power 1 plus 2. The entry in the first row, second column, first row, second column, first row, second column. So you're left with minus 3, 5, minus 1, 1. First row, second column. Minus 3 plus 5, 2. Minus 2. Let's look at this one, 1, 3. Now, C13 is exactly what? Is minus 1, 1 plus 3. You know, looking at the entry in the first row, third column, which is minus 3, 7, 5 minus 3, which is exactly 1 there, and this is 9 minus 35. So what is 9 minus 35? Right, so you can easily get that one is 26 negative. Now we're going to find C21. Let's write a matrix A here so that we can be able to quickly find the cofactors. And then the matrix inverse of the 3 by 3 will be evident to us. The couple of methods we use to find the matrix inverse, amongst others, would be the C21. The entry in the second row, first column. Second row, first column. Here. So if you block these row in that column, you're left with 5, 0, minus 3, 1. So is minus 1. Okay, we continue. We continue. So is minus 1, then you have 5 here, and this is minus 5. So that's what we have here. Then you have C22, which is minus 1 to the power 2 plus 2. Okay, 2 is this one. 2 is this one. So which means we block this and that. We'll have the 2051. Okay, this is positive, and therefore 2 by 1 is 2. C23. Okay, so 2, 3 is this one. This row blocked and that column blocked. We're left with 2, 5, 5 minus 3. 5 minus 3. And this is minus 1 to the 5th power, minus 1. This is minus 6 minus 25. So what is the answer? Is it 31? Next, we look at C. Okay, so we got to C 23, then we can get C31, which is minus 1 to the power 3 plus 1. Now C31 is this one, so we have 507 minus 1. Which is minus 5. So what is the answer? Well, we need to first just to remember what the matrix A is. Actually, it is 2, 5, 0, minus 3, 7, 0. Minus 1 here. 5 minus 3, 1. Okay, like I just said, this one is a minus 1. It remains to find C32, which is minus 1 to the power 3 plus 2. Then we have 3, 2 is this one. So we block this and that, which is 2 minus 3, 0 minus 1. Which is exactly minus here. And minus 1 times minus 2. 2. C33. Minus 1 to the power 3 plus 3. 3, 3 is this one. So you have 2, 5 minus 3, 7. So this is exactly the plus 1 because it's minus 1 to an even number, the even number 6. So that 2 by 7 is 14 plus 15. And this is 29. Okay. So now thus the cofactor matrix. Cofactor matrix is given by C. Which is C11, C12, C13. C21, C22, C23, C31, C32, C33. What is C11? So now this is the first row is 4 minus 2 minus 26. 4 minus 2 minus 26. Let us check the second row, C21, C22, C23. So it is minus 5 to 31. Minus 5 to 31. Minus 5 to 31. Okay, this one is minus 5 to 29. So now then this is the answer for the cofactor, and then now we're going to get the so let's just I want to pause to breathe a little bit and check the cofactor matrix. Just for just a second. Right. Okay, I'm just observing just to make sure that we have the correct cofactor matrix here. Just in a split, in a couple of seconds, I'm just going through each of the entries just to make sure that we do not have a wrong entry in the matrix, in the cofactor matrix, because then our inverse is going to be wrong. I need to just detect it now because is one important step. This is one important step. This. Okay, excellent, 100%. Okay, now then there's something we call the adjoint, which is the transpose of the cofactor matrix. The adjoint is the transpose of the cofactor matrix. So which means that C transpose is the adjoint of A. So the adjoint is the transpose of the cofactor matrix. So now if you find the transpose, what is the transpose? Right, the transpose is going to be exactly 4 minus 5 minus 5 minus 2, 2, 2 minus 26, 31, 29, like so. Okay. And this is then the adjoint with the determinant of the matrix A. We got it to be minus 2. Hence the inverse. Hence the matrix inverse of A is given by one over the determinant of A multiplied by the adjoint of A. So what is the adjoint of A? We've got it. So here you have 4 minus 5 minus 5. minus 2, 2. Minus 26, 31, 29. Okay, so this is what we get. So it means, therefore, the inverse, if you multiply through, is exactly minus 2, 5 over 2, 5 over 2, 1 minus 1 minus 1. 13 minus 31 out of 2. Minus 29 out of 2. So that is the answer. And that is the answer. That is the answer. And this is the inverse. How do you check if the inverse is correct? Check. Let's do a check. To check if the inverse is correct, we multiply the matrix A inverse with the matrix A, and the result must be the identity. So let us multiply this. So this is exactly minus 2, 1, 13. Minus 2, 1, 13. 5 over 2 minus 1. 5 over 2 minus 1. Then we have minus 31 out of 2. And then you have 5 over 2 minus 1. And you have minus 29 out of 2. Like this. Okay, and then we multiply it through by the matrix A. And the matrix A is this one here. Right, the matrix A is 2, 5, 0. Minus 3, 7, minus 1. 5, minus 3, 1. Like this. So you have, therefore, this one is A inverse times A. Right, so you continue to multiply these matrices. Let us multiply this row by this column. So this times this minus 2 times 2 is exactly a minus 4. Multiply this with this is actually minus 15 out of 3 out of 2. Minus 15 out of 2 plus 25 out of 2. So minus 15 out of 2 plus 25 out of 2 is actually the same as 10 out of 2, which is actually 5 minus 4, 1. So we have a 1 there, and multiply this row by this column. We have 2 by minus 5 is actually minus 10 plus 14 out of plus 35 out of 2 minus 15 out of 2, and that's 20 out of 2, which is 10 minus 10, 0. This with that, minus 2 by 0 is 0. 5 out of 2 minus 5 out of 2 plus 5 out of 2 is a 0. Okay, multiply this with that. So it's exactly 2 plus 3, which is 5, minus 5, 0. This with this is 5 minus 7. Right, 5 minus 7 is minus 2, and then plus 3. 1. This with this, that's 0. 1 minus 1, 0. This with that. So is 26 minus this and that. Okay, so check these relatively large numbers. Let's see, 13 by 2. You have 26. This by that is actually the same as a 93 out of 2. And this with that is a minus, okay, because 5 by 20 is 100. And then 5 by 9 is a 45. So 145 out of 2. But obviously this one is 52 out of 2 plus 93 out of 2 minus 145 out of 2. And therefore, if you add these two guys here, this one here is actually 145. So the result is 0. Now this with that is as well the same as what? Let's just check this quickly. So let's just clean this up here. All right, we're just finishing this and we're going to see what else to do. I'm going to give you homework. Just going to check the time as well. So you have these together with this. So 13 by 5 is 115. And you have that this together with this. Right. This is 7 by 30 is exactly 210. And is 210 and 7. So is 217 out of 2. And then now this one here is actually a 60 and an 18, which is a 78 out of 2. This one is 230 minus 217 minus 78 out of 2. The
Sorry, sir,
answers.
the last one is not 78, it's 87.
Okay, okay. Yes.
It's late, it's fine.
Yes, just switched around. Okay.
Yeah.
Anyway, you're right. That's fine. Yeah, it's 87. Well done. Excellent stuff. So I'm happy that you really are focused. So that is 87. Just checking this up. Okay, so if this is 87 here, let's see what we're getting. Okay, I'm expecting the result to be 0. Just cross-checking these things here. So that's exactly 230 minus 217 minus 87. Okay, where's the error? If you multiply this,
So the
this
first
one
one
must
is
be
60.
plus. This must be plus
fir-
this.
Yes, and the first one must be the 13 times the 5 must be 65, not
Yeah,
115.
yeah, definitely. So it just became too large. I'm
Yeah,
happy
it's
that you are
65,
wide awake. That's actually a 65. Wondering
which
why
makes it one. Yeah, it makes it 130 there at the bottom.
130.
Yes.
Okay, so it must work out now. 130
Yes, and then it's
minus
217 and 87. Yes, it's supposed to work out.
217 plus 87.
Yes,
Well
it's 0.
done. Is a 0 here? Okay, the last one. So the 13 pi, this is going to be 0. And this here is going to be, okay, this appears to be working out without much challenge. Just check. Okay, it must be a 1 here, but just cross-checking the last one. But yeah, I just believe that it must be, it is the correct thing we have. So this pi 0 is 0. And this pi, that is that 1 out of 2. And this by that is minus 29 out of 2. And therefore, obviously, here is 2 out of 2, a 1.
Yeah.
Okay, I mean, what is the meaning of these? Well, the conclusion, therefore, is that the matrix inverse of A, okay, so you're going to write it like this. Conclusion, hence. Right, so hence, if the matrix A is, just going to write the matrix A down. If the matrix A is twice 5, 0, 2, 5, 0, minus 3, 7, minus 1, 5, minus 3, 1, then A inverse is minus 2, 5 over 2, 5 over 2. Minus 2, 5 over 2, 5 over 2. 1 minus 1 minus 1. Okay, and then what do we have last? 13 minus 31. 13 minus 31 out of 2 minus 29 out of 2. Minus 29 out of 2. Okay, so yeah, that is what we have. And this is awesome, awesome stuff. But I want to give more problems here. I want to give more problems here. Here is the problem that I'm giving now. This problem I'm giving is an exercise. It's an exercise. Here is your home activity. Right, so the home activity is an interesting one. So let me just give this one. There's a principle of what we call the Kirchhoff's laws in electricity. Physics. Kirchhoff. Kirchhoff's rules. The couple of rules, right, are applied to a circuit. And the following equations are obtained. Right, and the equations are minus IC (16IA) plus 4. IC equals 0. 12IB minus 4IC equals, okay. I need to change something here. So these here have to be 100, and these has to be a 60. And the question is determine the indicated currents. The indicated currents IA, IB, IC, using the inverse of the coefficient. Matrix. Okay, so this is the question. And question number 2. Home activity part 2. The frequency. The frequency F associated with any moving particle is given by F equals mv squared out of 2h, where h is a constant. Constant of the percentage error. In the measurement of M is 0.5%, and the percentage error in measurement of V is 0.3%. Calculate the maximum percentage. Calculate the maximum percentage error in F. Right, so those are the exercises that I've given here that we're going to try. And the matrix question on Kirchhoff's laws, just an application like we looked at the one we did earlier of the RC1, RC2. It becomes any application. Normally, the applications appear to be stemming from physics, but they can stem from other parts of computational subjects. They can stem from economics, etc. But yeah, in this module, the physics questions are a bit more popular. Anyhow, right, so, and even this one, we're just looking at the percentage error in the frequencies and things. All right, so I think that we started at what time? Can you remember the time I registered? What time did I register? 40 something.
Yeah, it was 41. 22:41.
Okay, I need to trust you there. Okay, so I'm gonna give a small little exercise now to see what you can do. I'm gonna give a little exercise to see what you can do, and what you can do. Right. I'm just 1 sec. I'm just gonna give you this exercise and see what you can do. I'm giving a small test because I'm trying to balance up the time. I'm trying to balance up my time, so it's pretty much what I wanted to speak about today, but there are too many things I still can speak about. But first,
Sir, sorry, sir.
yes.
Tell me, is there any apps that I can use? I have a few exam papers here, but without memos. Are there any apps that I can use to check my answers or to verify my answers?
Okay, that's a good question. Yeah, I'm gonna give you information about some apps.
Okay.
I'm gonna give you information about some apps like there's an app called Symbol Lab. Right,
Okay.
there's an app called Symbol Lab. Okay, like symbol is an app that is called Symbol Lab. Normally, I use the apps when I'm doing long calculations because so there's human error. There's always a chance of human error. So this one is accessible on is readily available on the internet. It can do the matrix inverses and the matrix cofactors. Like when I was doing the calculations, I was just also doing it on Symbol Lab to check if I made no mistake.
Okay.
So it's awesome, 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 awesome. So um
Okay.
okay, I'm still yes, please.
Sorry, and that will work with the algebra and the integrals and everything.
Yes, most definitely. But normally, or it gives the answers or and the steps. It gives briefly the steps, or you can be in a position to just know what if there is a mistake. You can be able to see, okay, the answer must be 3,
Yeah,
but it's if you're getting a different answer, etc., etc. And so it's able to sort of assist in that respect. Okay, so now I want to give you one question here to try because I want to see what you can do. I want to see what you can do here. All right, so now, for example, if we want to find the derivative of, here is an exercise, a pop quiz. Right, if I'm to record this as a pop quiz, and in this pop quiz, we're asking the question, if V is pi r squared h, find the small change in V. Okay, this is a pop quiz. The pop quiz can come from any topic, please, because it's exam revision. So I would not always bring from exactly the kind of stuff we're doing now. It would just be anything from the curriculum.
Okay.
Okay, if this is the case, what do you think the answer is to this?
The small change, I would say.
I'm just teasing, but yeah, it's part of it's part of the curriculum. I mean, it came in an exam. It came in in one of the exams, you know.
Yeah, yeah.
So I'm just testing you. You'll forgive me, please. I'm just putting you on the spot. It's not fair because I did not speak about small changes today.
Yeah, yeah.
So it's not fair, but it's exam revision, so I can bring anything. And I'm bringing this because we're gonna do the corrections now, and then you're gonna like recall and be familiar with the thing. Anyhow,
Yeah, yeah.
no worry. Take your time. Um, because this will sort of be our last exercise for today, and then we'll meet again tomorrow. And tomorrow I'm gonna be bringing more things full power. There are things we have not spoken about at all, like totally. So we're gonna discuss them tomorrow. But yeah, I'm gonna check the time tomorrow. My apologies for today because the load shedding was an issue, and so I had to move the lesson to a later time. Um, all right.
Let me just check. No, that one will be-
You see, tomorrow the load shedding schedule is the same.
Is your load shedding the same time?
The same time as today. I mean, yeah, so it's gonna be no power from 6 to 8. So the power is gonna come back like after 8. Meaning, I'm just checking the schedule now. So meaning that the best would be to schedule our time from like 8:30. Yeah, I must apologize because I would have liked it to be like at 6, but I can see that the schedule is the same tomorrow. From 6 to 8, there's gonna be no power. The problem with no power is the network might just be too bad. Even if I can,
Yeah, yeah.
even if we can do the transmission, but you know, there might just be lots of issues with communication.
Yeah, yeah.
Yeah,
Yeah,
so meaning that 8:30 is the perfect time. Yeah, so please just work on that. But I'm just letting you know that from the usual 7 is not going to work because I would have liked 7, but I can see that we have no power from 6 to 8 in our area, or at least in my area. Okay,
yeah, yeah.
right. So I was asking this pop quiz, please. What do you think about it? Just a tease, just there to tease you a little bit, and then do corrections, and we call it a very good evening. And then you're gonna do the other two I gave. Okay, but this is also gonna give a hint. But yeah, um, tomorrow I'm gonna spend a bit more time on the small changes and the changes and all these rates of change and things. So
Yeah, it's this one is you caught me off guard with this one. I'm not gonna lie. Uh, I also struggled with
that's fine.
the
Never mind. Never mind. I mean, I know I'm putting you on the spot. Okay, but I'm gonna speak about this now. Here's the solution to this. Right. Here's the solution. So the solution is that if you have V equals pi r squared h. Okay, this is the volume. So this becomes what you call
yeah,
the volume of a cylinder.
yeah.
Right. So the volume of a cylinder. How do you find the volume of a cylinder? Well, by a cylinder, we mean the 3D shape like this.
Yes.
Okay, so it's a cylinder, and then we normally say this volume is area of base by
By
height.
height.
Well, obviously you can agree that the base is a circle, and also obviously you can look at it from both ends, but the base and the top are both circles, so that you can say area of base by height, and that is the volume. But okay, that is done at school. But for us at university, we're interested in finding this. So there are two things we find here first. So we find first the partial derivative of v with respect to the variables here. So the
Yes.
partial derivative of v with respect to r, the derivative of r squared is 2r. So that
Yeah.
becomes 2 pi r h. But we also proceed to find the partial derivative of v with respect to h. Right, so derivative of the h is 1. So this is pi r squared. Meaning if you have been given v to be pi r squared h, so if v is pi r squared h, then we can be able to find the small change in v, which is what I was interested in. So the small change in v, and I'm going to speak about this in detail tomorrow, is the partial derivative of v with respect to r times the small change in r plus the partial derivative of v with respect to h times the small change in h. So which means the small change in v is a partial v partial r, partial derivative of v with respect to r is 2 pi rh. So it's 2 pi rh. And then we multiply that by the small change in r. And the partial v partial h, we saw that it is pi, it's exactly pi r squared. Pi r squared, okay? We saw that partial
Yeah.
v partial h, partial derivative of v with respect to h is pi r squared, because the derivative of the h with respect to h is 1. Okay, but small change in h. And this is the answer. So hence, the partial derivative is 2 pi r h r plus pi r squared h. Anyway, this is the answer, and that's what I wanted.
Yeah.
But obviously, this answer here is useful, because we can use these to um, perform computations if you have been given the small changes, like the small change in the radius is a percentage and the small change in the height. etc. Because there are errors in the measurements of the radius and the height if these things are done in industry and one manufactures a cylinder in industry. So there is always a chance of what? Of an error. Okay, so now this concludes our discussion today. I'm gonna make the video available for you to watch and obviously have everything, but also to see the exercises I gave. I mean, you can always fast forward the video because it must be about 2 hours long on average, so it might take time for you to even watch through. But now you can fast forward the video, be able to take down the exercises, try the matrix question, try the question I gave on the frequencies, etc. And also, yeah, that'll be it. I don't like giving lots of activities as part of one's home activity. Yeah, but thanks a lot for today. I must be able to see you tomorrow at 8:30 p.m. Okay.
Yes. Thank you so much.
Yeah, thank you so much and have a good evening. The recording is coming the next couple of minutes. Okay. Yeah. I'll
Thank you
just
so
need to
much.
upload
All
it
right.
first. Thanks
Okay.
then.
Thank you.
Have a good
Okay.
evening and goodbye.
You too. Okay, bye.
Goodbye.